wouldn't say that they're always like a solution architect. It's more like more like a simple architect.
Can you explain the connection model of PostgreSQL? Why do we need a proxy like in the first place?
Sorry?
For instance, if you go like to very popular language like PHP, I don't think there is a pool like on PHP side.
I'm not a PHP expert.
Hello and welcome to a new episode of the Architecture Deep Dive podcast. I'm Oleksii Petrov, Solutions Architect at Husqvarna Group. In today's episode, we are diving deep in the world of high-load systems and exploring a key component in scaling PostgreSQL database, which is PGBouncer. We'll discuss challenges and practical lessons from running Postgres under heavy traffic. And to unpack this topic, I'm joined by a very special guest, Vitaliy Kharytonskiy, Solutions Architect at Prom.ua. And for those of you who don't know, Prom.ua is one of the largest online marketplaces in Ukraine. Their platform handles significant traffic and operates robust self-hosted PostgreSQL infrastructure. So there is a lot we can learn from their experience. Vitaliy, very welcome to the podcast. And to start off, could you tell a bit about yourself, about your role, about your work you do at Prom.ua?
Thank you for such introduction. I wouldn't say that they're always like a solution architect. It's more like more like a simple architect. And in some parts regarding the application architecture, database optimization, and stuff like this. More high-load stuff. If we are going to talk about like databases, we have some extensive experience in Prom.ua with huge loaded databases, primarily Postgres, because it's been like a staple database for more than 10 years already, and it's constantly growing. The size is constantly growing. The application complexity is growing. So we are constantly challenged by the needs of optimization and like running a stable database, a highly available database, and stuff like that. So we employ some number of tools to achieve those goals, I'd say. And probably one of the cornerstone of them is PGBouncer, which is also been like a basic tool for as long as we use Postgres, because it's the recommended, highly recommended setup to use Postgres with PGBouncer in probably almost all scenarios except the most light loaded ones.
Of course.
Yeah.
I think we'll go into that topic, like in topic of PGBouncer during this conversation, of course. But to start off, maybe could you tell a little bit about the scale from Prom.ua? Like, how many databases do you have? Like, what is your deployment setup? Like, tell a little bit about that.
So we have. I don't want to miss, but we have more than 100 databases used, like Postgres instances used for the application. Probably like the amount of transactions per second is in thousands. We have a very high loaded write cluster loaded replication, like 200 megabits per second of replication on the one cluster, which is kind of challenging because we have to replicate between two countries, between our backup data center in Europe and Ukraine. So we have to keep them in sync, and it also kind of straining. We have our largest cluster is 3 terabytes in size, which is kind of problematic because you need to constantly maintain the the size of the cluster. It's constantly growing. You have to repack it or vacuum it. So it's also one of the challenges. Yeah, so that's in short, that's probably it. I mean, and also all of the uh, all of the Postgres clusters are like self-hosted on premise. They're not using any self-scaling AWS stuff. That's why we also need to tune them, set up them, monitor them, and make sure they are working 24/7.
I think in one of the talks you mentioned like that number that we see currently on the slide, 243 PostgreSQL instances over 5 data centers. So that's huge traffic and huge deployment, especially if you say you go self-hosted. So that's insane in my view. Like like a lot of architects are spoiled with cloud technologies and being and having that access to database as a service, like when you can spin up any number of them, but you do not have that burden of managing such many instances of the database on your own. So in that regard, like, could you talk a little bit about that self-hosted approach? Like, why did you go self-hosted versus cloud?
Because that's like that came naturally because Prom.ua is a Ukrainian company, so we don't have we don't have a large budget for the infrastructure which is required for the cloud, and like as we um, as we grew more and more, we understood that we will never probably achieve this kind of amount of money which we need to pay for this amount of scale on the cloud. And this is not like our situation. Even Western companies, like US companies, shift to on-premise because it is very, very expensive to go on cloud. But any serious loan, like I mean, like thousands of users, and you are easily going over budget on cloud, and it also kind of gives you some amount of control. You can make things cheaper. You can make things more obvious how they work, and yeah, and you can provide more like transparent service because on cloud you have a lot of layers, you have abstractions, you have uh, stuff that you need to understand how it works. You have all this complex machinery which you need to understand how cloud works. On-premise, a lot of stuff is simpler and more accessible, and you can manage it with less people, with even less people that you need to manage cloud. I mean, of the same scale.
Yeah, makes sense. And while you were talking, I calculated that 243 instances divided by 3 gives me 81 sets of master and 2 replicas. Is this your typical deployment when you go like with 1 master and 2 replicas, or is it just a coincidence that it can be divided by 3?
No, it just depends. So for some databases, because we are running a lot of databases as virtual machines, we don't need a lot of redundancy because we are not afraid that like the hardware will fail because we can always move the VM to another host. We are not afraid that like underlying storage will fail because it is also replicated. So some of the clusters we run like a single node, like master. Some less loaded clusters. Some of them we run as like leader follower. Yeah, and also the largest cluster has basically a lot of replicas because it's like the main database which gets most hits.
Yeah, I see. And like with the number of databases, like, is it driven by the microservices? Do you use microservices, or like do you go with services? And this is like just a reason of like having one large cluster of many nodes. So can you talk about that a little bit?
Yeah, the databases are divided between microservices. So this is like a typical to have a service and its database, like as a self-contained mini infrastructure. So we are trying as much as we can to avoid huge clusters, because it's really pain to maintain them. In the sense that you can't you can scale vertically only as much, but at some point you hit like diminishing returns. You cannot buy like a bigger server. You need to split the load. You need to share the load between virtual machines, which have even less performance than like real hardware, real storage. So you need to split them as much as we can, and we are splitting the database for some time now, and that's why we have so many different clusters, but we still have one huge database with the bulk of the content that we serve.
As we discussed previously before this recording and on one of the talks, like this infrastructure kind of impossible to run without a PGBouncer, right? So like this is kind of an essential tool in it to supply like the demand of all of the clients you have. So
yeah. So this is kind of recommended setup even for smaller databases, but for in our case, this is probably the only way you can run it. You can use like in place of PGBouncer, you can use some other proxy. But as we like spent some time with it and we tuned it and we understand how it works, and we are like, we don't need to double check ourselves. We know that that it will not like it won't fail us, so that we still use it. And frankly, there isn't so many like different options with the same number of compromises. So we have, for example, we have like a PG pool, but it's very slow because it works not on the connection level, but on the application level. So it parses the query. It can do some additional logic, and it is useful in some scenarios, but not in our cases. You have pgcat and supervisor, which are more modern alternatives. They can do multi-core, but they also have their own drawbacks, and they are relatively fresh. So they are probably not as mature, as stable as PGBouncer.
I wanted to maybe start a little bit before the alternatives, before discussing the options, just to talk about the PGBouncer itself. I mean, not every database requires some kind of database proxy, right? So we have some databases that run on their own, like, I don't know, MySQL, MongoDB. There are some proxy available, but they're not kind of required, as in the case with Postgres. So I just wanted to ask you, like this explanation for people who are not unfamiliar with the product, with the PostgreSQL databases. I know that there will be some watching this podcast. So can you explain the connection model of PostgreSQL? Why do we need a proxy like in the first place?
Yeah, it's a basic architecture of Postgres. Postgres has like two parts. It runs in like there is this PG Postman process which accepts the connection and checks authorization and stuff like that, and then it hands over the connection to like the main process, which like forks itself, and you are separated into a separate Postgres process. This is kind of neat because, for example, you can do stuff which you cannot do in other databases or like data solutions, let's say, because they all run in threads, which means that you cannot kill the query cleanly. You cannot kill the thread from like outside, not on all platforms. For Postgres, you can just kill the process and it's dead, and that's all. And this way, you can easier implement like timeouting logic. You can implement user interruption, and it has its own merits, but it has one huge drawback, which is that it has to fork itself, and forking is kind of very heavy process and it needs memory. If you have a lot of forks of the process, you still consume memory, even though the memory is shared between forks, but you still consume it. So PGBouncer fixes partially this flaw in the way that it can reuse the connections that are already established, and Postgres doesn't need to fork as much. Also, it can reduce the existing forks, which means that you don't need to create another fork to serve the query, which kind of fixes the problem. I mean, for a high load, it's necessary. It fixes this forking problem. It's a very common case of Postgres failing when it just runs out of memory to create another process, and you can serve more connections, and you just killed by out of memory error. And PGBouncer also kind of fixes that, not in all cases, but in like a normal workflow, it can fix that. Yeah, that's why you need it for a high load, as I said. So we have like this a process per user, and PGBouncer allows us to have multiple users per process. Like for example, for a transaction pool, you can have like 2 connections serving 3 queries. For a statement pool, you can have even 1 connection serving all of the queries if they're not coming simultaneously.
Yeah, I think for people like coming from different backgrounds, it might be there are some similar architectures in different languages and tools, not just databases though. So for example, like from PHP world, we have this PHP FPM that manages processes for PHP basically, and we put something at Nginx to manage this connection async logic, like not to overload the PHP FPM, because we also have that process per request. Or for example, in Java Tomcat, there was like servlets that did the same logic before the NetT was used, like in many installations. Or like Oracle, I think they have a similar model. They just have this proxy built in, so they also spawn a process like per like a fixed number of processes, like per cores or double number of cores, depending on the strategy, and they have this proxy in place. So basically, what we are doing, we have the middleman that handles the connection with database, like having a fixed number of connections, right? And we have it accepting queries from outside and pulling those connections through those queries through those connections, right? And oh, I see like the gray slide that you have here. I think there are like multiple ways of doing that. Like, where do we split? What do we pull through the connections, right? So, can you like talk a little bit about those modes or those options we have with the PGBouncer?
Yeah, so this is like a different behavior. You have like standard session pooling where each connection basically on the client side gets its own connection on the server side, but the connections aren't closed immediately on the PGBouncer side, so you still have a case where Postgres opens up forks 10 times and has 10 processes listening for processing the connections, and PGBouncer doesn't close them from his side, so they are not constantly dying and spawning. But still, you will have as many connections to Postgres as you have simultaneous queries. In transaction mode, you can have less connections per user, because you can have like queries switching on transaction. And in statement mode, you just like can push all the queries through one single pipe and get all the results, and you don't have like transactions. But it's the most like unsafe mode because you have no transaction boundaries and anything can happen. But I think it's okay for some redundant scenarios, like reading from replicas. It can be okay. So
do you have any limitations with transactional mode, because it seems like an optimal one?
If you open a transaction, you hold the connection until it closes. That's the idea. So if all the clients suddenly open transactions, you will have as many connections as clients. Yeah. So for stuff like write heavy scenarios, it's not very it doesn't make a lot of sense to use this mode.
And I think there might be some variables during a session, right, that you do not want to set, maybe something like that. Avoiding those because you can basically go into another instance or another connection that doesn't have that variable set. If you're doing between transactions, like set a variable, run a transaction, then run another transaction, expecting that variable to exist in your connection session, you might get to another instance and use another session, right?
Yeah. But this PGBouncer isolates this inside, so you don't see that you are using the same session. It clears the connection between the queries. So for you, it's very, very transparent. There are cases when you have problems with that, like if you are working in a transaction mode and you set a timeout, it doesn't work because you will have basically you will get a different connection on the next query because you don't have your own dedicated connection held on the side. But there are some gotchas, but they are very, very. You have to be very. Do a lot of stuff with the database to stumble on that.
And like this problem, like when application opens lots of connections, I think it was solved in a way in application itself, right? So many applications started to use something like database pool, not to create as many connections as they would like to, like on every request and on every operation.
Yeah. This is like a regular feature in all the database drivers, like a scale alchemy. Probably in all the languages you have some kind of pooling mechanism, which is kind of neat, except that you can fully control it only when you have like one instance, for example, of an application. And then you know that you have some limit on the pool number, and you won't ever go above this limit. But if you have multiple services, you have some autoscaling, you have stuff like traffic spikes, then you will probably go over the pool size, or you need to constantly like tweak it and manage it and make sure that for every like database cluster you have an appropriate amount of appropriate amount of maximum pool connection in all the application instances and the appropriate number of application instances. So it kind of goes out of control, and it's hard to manage in like if you have like 100 microservices or like 50 microservices. You need to manage this carefully for each of them, which like turns into nightmare. Wherein if you are using a database proxy, you can just use just constantly open and close connection on the application side and manage all those limits on the proxy side, which makes application simpler and more reliable because pooling involves locking, it involves like probable race conditions where you are releasing the connection to the pool and someone else is using it, and you don't need it at all. You just can open and close connection all the time. And the database proxy just manages this limit. So this way you need only to manage the number of proxies versus the number of connections allowed for each proxy.
You still need to do some management of different applications, right? So like, let's say I have like service A and multiple instances of that, and then service B, multiple instances of that. So technically service A can like use all the pool available in PGBouncer and do not give some space for service B to run a connection, right? How do you prevent that?
You can just split them into their own like connections inside the PGBouncer. So this is also kind of neat stuff where you can have one connection one connection which is allocated to one service, and another which is a connection handle, like address, which is allocated to another service, and they both are connect using the same database, for example, which is not very okay, but it can happen sometimes. And you can limit them in their own connection handles. So this way,
You mean I will have like a dedicated pool per service, right?
yeah, like a dedicated tool per set, which is really not possible if using the just direct connection to a database.
Yeah. Do you do any authentication on PGBouncer, or do you authenticate like on a database?
Yeah, PGBouncer does basic authentication, just checks that password hash matches, and that's all. So it doesn't do any permission checks. It just lets you through, which also lowers a bit the load to the database, because in case of like errors or stuff like this, you don't need to check it in the database itself. You can just drop the connection on the PGBouncer side.
Yeah, so some type of pre-check, right? So like just a sanity check. On one of the things you mentioned previously, while you were talking about the alternatives of PGBouncer, you mentioned that other tools are multi-threaded and PGBouncer is single-threaded. Is it a problem, like that it is single-threaded?
Yeah, there is kind of problem that in that it cannot use multiple cores, but it's really not an issue, because you can scale it to multiple instances in Kubernetes, for example. So you really don't have this problem of a single core problem. You only stumble into it if you have a very high load and you cannot scale it across different machines or something like that.
If we cannot have it multi-threaded, can we run just one more process of PGBouncer to solve that?
Yeah, we can just start another process and like share the load between two processes, and you have two cores, three processes, three cores. That's all.
Yeah. Okay, so now I wanted to talk a little bit about the practical examples of PGBouncer. So you mentioned that your infrastructure dates back in 2008, and a lot of things has changed from that time, like especially in database world. So did you have like this same setup through years using PGBouncers, or did it evolve in a way? Can you talk a little bit about that?
Yeah, we had some history of evolving, like the way that we deployed the applications, and it also affected the way that PGBouncer is deployed, because it's also an application. So we had sometime we had like a dedicated PGBouncer which ran on its own server, and we went to it, and then it went to a database. But this was not like an optimal way, because it's hard to scale this. It's very costly to maintain this, because you have to take care of the servers, update them, move them. So we kind of distributed it across all the application nodes, which kind of works, but it's also not very optimal, because you lose this control stuff. You have as many pools as you have server nodes, and it kind of loses a bit of its purpose. We tried experimentally to embed it on the database server, but it doesn't work really good, because PGBouncer creates a lot of network load, which makes database servers slower, because they compete for the network capacity. Yeah, so finally we came to most obvious scheme. We have PGBouncer running in the Kubernetes as an application. We can distribute the load via service, Kubernetes service, and we can have it connect to a database which runs on its own dedicated virtual machine.
Let's discuss this setup, and please walk me through some of the aspects here. So we have an app that lives in Kubernetes, right? You said you deploy PGBouncer as a service. So like we have a DNS name of PGBouncer to connect it, right? So like, would it be a service per database, or like would it be like a service, one service for all databases you have?
So it has pools for like all databases we have. Where we also split it by namespace and stuff like that. But it has in its settings it has all the databases that we have.
Okay.
Yeah.
Yeah, so the app then like resolve that DNS namespace of the PGBouncer connects to a random one, right? So you do
Yeah.
not like there is no load balancing apart from being like DNS load balanced.
No, it's the load balancing between the PGBouncers is done via Kubernetes service, and the load balancer between the database replicas is done via DNS. So yeah, we have like two layers of load balance.
Okay, so load balancing between the database replicas, it means like load balancing on read, right? Because if you say replicas, we cannot write any replica, right? It's not masters.
No, it's replicas. If you have like master database has like it's Postgres, so it has one target instance.
So will you have like a different pools in the PGBouncers for writes and different pools for reads?
Yeah, it's split. It's usually split into different pools. Yeah, not usually. It's always split into different pools because it's different connection handles even. For replica, we have like a read-only handle. For master, we have just a regular handle.
So for each database, you'll have like basically two domain names, right? One for reads, one for writes.
In some cases, yes. In some cases, we have like one master, which can be a replica. Which is used for read only and write queries.
I see. And like apart from DNS, there is nothing else in front of database, right? So you do not put the HA proxy or something like that.
There is only DNS. If we have multiple replicas, they have multiple IP addresses, and just PGBouncer just has its own pool for different DNS addresses inside it. So it also kind of tries to distribute the queries evenly among them.
So basically, if you check this diagram and the very first diagram, they are kind of similar, apart from Kubernetes, right? So we didn't have Kubernetes in 2008, but like this setup, when you have databases and cluster of PGBouncers.
It doesn't change a lot. It works, I guess.
In some cases, I saw people use like the approach that you mentioned also, like when you have this PGBouncer with an application. So they would use a PGBouncer with database server, like one for server that knows that server capacity, like how many connections it can handle, like how many threads it should open to a server. And on the other hand, you have like PGBouncer on the application side, which kind of prevents application of issues too many requests. Did you consider that, or is it like too much in your case?
No, that's like kind of too complex. I think. It's very complicated to manage.
Maybe it can be useful, like for languages that does not support like some kind of pooling on their end. For instance, if you go like to very popular language like PHP, I don't think there is a pool like on PHP side. You can try use persistent connections, but this is not the same.
Yeah, but it doesn't. I think it depends on the library. I think some more like sophisticated database libraries for PHP have some kind of pooling. Probably should have. I'm not a PHP expert, but it's kind of very basic feature.
No problem. So yeah, you sneak peek like into the next slide with the actual pod. So like let's go there. Like I'm really interested what you got.
Apart from the deployment configuration, we also change how the application works inside. So at the basic level, we have PostgreSQL process, which is deployed in the pod. Then we added like a config watcher, which will reload the process each time we change the config. This is crucial because we don't want to restart it, which leads to reset of connections. We want to just reload the config and move on. Yeah, it's a basic like a shell script, but still. Then we added like a metrics exporter, which allows us to see what's going on inside the PGBouncer across all the databases and maintain like a wider picture of the all of the clusters that we have, of the like the query time, how many active clients do we have, and stuff like that. Then we, after some amount of incidents connected to problematic networking and some not optimal setups of, again, related to like virtual machines and stuff, we added a health check pod, which allows us to track the liveness of the PGBouncer itself, because stuff happens on the networking side, and some pods may become stuck for some reason. So we need to restart them automatically if, in case of severe network degradation, they become unreliable. We experimented with a proxy for database liveness checks, but it's not it's also a bit more complicated. It works, but it creates like a double network load, because you have two proxies. You have a PGBouncer, which is a proxy, and you have a proxy, which is a proxy, and they all proxy the same traffic, and they all use up CPU on twice. So we have like one connection and it's proxied twice. So we have twice the CPU load in one pod, which is kind of not optimal. And you can see that you have a lot of interrupts because of this. And sometimes this leads to like contrary effect, where you have database is working, but you have an overloaded CPU on some Kubernetes node because you have the proxies running inside. Yeah, so we decided to kind of optimize the scenario by using a DNS server embedded into the PGBouncer. This way, the DNS server can serve as a health check itself. So it regularly checks the database, and if the database is not live, it just excludes it from the DNS response. This means that after some short amount of time, PGBouncer stops connecting to this database instance. And we can see this picture, like some of the database clusters became unreliable over time, and we switched off, then switched on, and it kind of looks like this. We have some plans on adding an additional log parser to enhance the metrics that we have, add some error checks and stuff like that. And probably do some better circuit breaking in case of overloaded database instances. So that's probably it regarding the current PGBouncer setup.
Got it. Like a lot of things to cover. Let's go back maybe like to that pod layout that you had. So a couple of things interesting you mentioned that I wanted to ask you more about. The first one is the health check. So how do you know that PGBouncer is healthy? Like, how do you know that you need to restart it?
We know that it's healthy if it doesn't have a lot of stuck clients. So the clients that are stuck waiting on some PGBouncer means that probably the high amount of probability it has problems connecting to a database, so we need to restart it. This is like a basic health check. So we just have check a number of clients that wait in the normal scenario, you'd have like probably 10 clients waiting on the spikes. But in problematic scenarios, you have like thousands of clients waiting. And if you detect this case, then you just restart the process.
How do you know it's not database problem? Like if say like database is gone, like it's not available, you also will have like 1,000 clients waiting, right?
No, we don't have waiting clients. Clients that can connect. This is like a different case. If the database is not responding, all the clients will receive an error. But if we have something like packet drops or connection problems, like connection takes too long to establish, then we will have this number of waiting clients, which will grow.
I see. Like there is one thing about that metric that you mentioned, waiting clients. As I remember, in PGBouncer, it's not like a counter; it's like an instant value. So, like depending on how often you read, you can miss those spikes of waiting clients if it's like temporarily. Like, do you have any recommendations from the inflows of health check or something like that?
I'm not sure I got it.
So let's say we check health check every minute, right? So we like every minute ask like, what is your number of waiting clients? So in PGBouncer, it's like just a number which changes. So it can be 1,000 for 60 seconds. Then like it can be 0 because they reconnected. Then it can be like 1,000 for another 15 seconds. Then it restored to 0. So it's not like in the Prometheus you have counters that you can see how it grow over time. It's at the time you read, you see the value, but it like you may read not in correct time to see that change.
We have this is okay to use like an instant value. You just check the current value, and because we set the bar so high that in any amount of time you should have like probably less than 10 clients waiting. But if you have like 1,000 clients waiting, which means that things are like very, very bad. That's why it doesn't matter what we check. I mean, we don't need to check like its behavior. We know that it's like a black and white situation.
Mm-hmm. Do you ever need like to auto-scale PGBouncer service, like to add more nodes?
We had autoscale, but this doesn't make a lot of sense. You can just scale it to some redundant amount, like you have like 50% of space, and it should probably be okay because we are not dealing with huge spikes of traffic, like twice the traffic or 3 times the traffic. So you can just scale it to whatever amount you is optimal right now, and you track it over time. If we probably we need to recheck those limits once or twice a year. It's not such a constantly changing value.
I see. You already mentioned that metric of clients waiting. Are there any like other metrics you need to pay attention to, like when you use PGBouncer?
You probably need to check the number of clients. You need to check the query time because PGBouncer problems like CPU, like if it's overloaded, it can cause additional latency on the query and stuff like that. So you need to check all the metrics and see if any of them are not looking good. That's it.
Like one of the DevOps engineer I worked with had, if you do not have an alert on the metric, do not add the metric like to your dashboard. So like it's only useful when you have some alerts attached to it and you have some action items if it's like passes those alerts.
No, but some metrics are kind of interesting to look at. You see stuff not alerting, but you can use the metrics for analytics. You see that you have databases which have a lot more like queries. You can check if they have the capacity. You see some growth over time. So it's kind of the more metrics you have, the more decisions you can make about the system.
I also was wondering about this DNS thing that you mentioned. So previously you also had a DNS. It was like in front databases. Now you take that DNS and put it into a container, or like put a reverse DNS to that DNS. Why didn't you manage that DNS in the first place, like which was in front of the databases, checking the health check?
No, this is we are talking about like a system-wide DNS, like I don't know, infrastructure-wide DNS. You cannot really manage it because it just contains records and that's it. The stuff we put inside the PGBouncer is like a DNS server with embedded health checks. So it's it has more logic, but it's also dedicated to this particular case task, and it will you cannot do it on the infrastructure scale. Doesn't make sense. That's why we did it the way we did it. So we put it inside, and then we just check from inside the PGBouncer pod if the database instance is still reachable. If it's not reachable, just exclude it from DNS response. And we can do it reliably only from inside the pod, because it also can fix the scenario that from some of the pods, some of the database clusters are not available.
Mm-hmm. Yeah, makes sense. Like the question about the infrastructure-wide DNS. So sometimes people would use something like AWS Route 53 that has some health check functionality. It's very limited, but still it works. So you can put some health check in the DNS provider, or try to manage that through the API. That's the reason I'm asking. But yeah, it makes sense that some of the containers may not see database because of the place where they are, because of the server, because
and it's also faster because you need to have some process which will call the API and some process which will and it's like a separate stuff. But you have this thing, it's like a self-contained. So you don't have it's not separated. You have this DNS server which is like running alongside the PGBouncer, which is checking the health check, and that's all. You don't have like a separation of services, and you can do interesting stuff inside, probably not only health checks, but also something else. Maybe manage the load somehow, but we're still not using this. We're still like we implemented it and it works, and it seems okay.
Like this is a very useful and in some cases standard feature when proxy can check liveness of its backends. Do you know that PGBouncer is planning to add such a feature into their core, or like is it something that they said that they will not implement? Have you heard about that? Anything?
No, PGBouncer doesn't have a feature of health checking. It can detect if the connection is not working for the new connection, for the old connection that's already established, and it can detect that it's not working, but it cannot, when it needs a new connection, it will try to establish it to possibly broken server. So we also wish to avoid it. So no, they are not planning to implement any health checks inside, and it's like their philosophy right now.
Do you see any development in that product? I mean, do you see any evolution of PGBouncer, or is
Yeah,
it pretty much static?
It's kind of evolves over time. It's a bit of traditional software in the sense that it doesn't have like huge leaps of features, but it evolves over time. So we are using right now the new features that were added in recent years, like networking timeouts and stuff like that, and statement timeouts, which were added like recently. I mean, 3, 4 years. But it's kind of very, very stable. It doesn't have a lot of new features and a lot of breaking bugs.
I see. And here you have this extra pod added, a log parser. Can you tell a little bit about that? What logs do you want to parse and why?
Sometimes there are like errors which are not going into the metrics, like client login timeout, which you can deduce from metrics, but you don't have, for example, you don't have a source, you don't have a client which is connecting, and it would be useful. You have authentication errors, you have errors like too many clients, which is also you don't have a metric for that, but you would wish to like detect it and have like a separate metric that you understand that this database in over like the number of clients. Yeah, and that is probably would be a useful feature, though it's not something that you always need. It's just that you don't need to go and read the logs yourself. You can make like a monitor and look at it, and that's it.
In that regard, I'm seeing logs. I'm curious, how do you debug client issues? Let's say some app cannot connect to database. Would you go to PGBouncer pod? Like,
Yeah,
what is the
yeah.
process of production?
You read the logs of the app. You read the logs of the PGBouncer, and probably you can also read the logs of the database, but it's usually not necessary. You just read the logs of the proxy and you see if it's incorrect, like authentication or probably some problems with the cluster itself. Yeah.
How do you know which proxy logs to read? Because you have a bunch of them. Like, do you go and inspect every each of them?
App usually issues like a lot of requests, so you just take one and statistically it's on all of them. Even if you have like a lot of proxies, statistically you have queries distributed all over. I mean, problematic queries distributed all over the proxies. So you don't need to pick one, find one.
Did you have like any like war stories like from production, maybe like unsuccessful deployment of PGBouncer crashed some like services, or database version upgrade like didn't work with certain PGBouncer or something like that?
Probably it's not a lot of interesting because, as I said, it's like a stable, mature software. So you have like stuff like incorrect limits, which means that you go over the limits. It's not like you have a lot of like interesting stories about it. It's kind of boring.
Mm-hmm. Okay. Yeah, a few more questions and we will be done for today. So, you mentioned the config parser and restarts of the PGBouncer. Like, how do you handle that in terms of like, does it happen without clients to connect? Like, is it like just a update config in memory of PGBouncer when config changes, or how it happens?
Just issue a reload query and that's it. We change the files and reload, and yeah. So it's transparent. It doesn't affect parse at all.
Okay. Is there anything you would like to recommend to our listeners, like if they want to have their self-hosted PostgreSQL database setup, PGBouncer, like any thoughts, any ideas, any takeaways?
Just like try to observe your requirements and try not to overcomplicate stuff. And also, the simplest architecture usually is the most stable. That's that's probably the takeaway.
Okay, yeah, I like this approach of lessen the amount of moving parts in the architectures as well. Vitaliy, thank you so much for joining today. Thanks for sharing. It's a unique experience of the big company using tools, and like your experience is unique. Like when you can talk on things in very deep manner, like and explain stuff how it works under the hood. So that's very useful and very helpful. Thanks a lot. Like and. It was a pleasure to talk with you, and I'm very pleased that you joined the podcast. So thanks so much.
Thank you for having me.
Guys, you know what to do. You can link, subscribe, share this podcast with your colleague who's working on the fancy PostgreSQL setup. I think they will value this share and join us in our new episode. So see you sometime soon.